Welcome to this video on exam revision for reciprocal trig functions. So what we're going to do here is just take a look at a few exam style questions for reciprocal trig functions. As always, pause the video, have a go at the questions as they appear, and then double check that your solution matches what we get on the screen. Other than that though, I think that's everything that we need here to get started. So let's begin now with question 1. Starting off with question 1 here then, where we have a nice easy question to begin with. So question 1 says, show that cosec pi over 2 minus sec pi over 3 is equal to -1. So this question is just using the reciprocal trig functions. So if we start with cosec, so we have cosec x here. So remember the third letter here tells us what this is the reciprocal of. So this is the reciprocal of sine x. This is 1 over sine x. So if we have cosec pi over 2, so cosec pi over 2, this is equal to 1 over sine pi over 2. Now just notice here, obviously the argument here of these functions, we're working in radians because it's pi over 2 and pi over 3. So if you don't recognize these exact trig values, just do use your calculator, but just make sure it's in radians mode. So sine pi over 2, that is equal to 1. So what I've got here is 1 over 1, which is equal to 1. So cosec pi over 2 is equal to 1. Now let's evaluate sec pi over 3 here. So we do this over here. So sec x, again, refer to the third letter here. So this is c, so this is cosine. So this is the reciprocal of cosine. So 1 over cos x. So if we have sec pi over 3, so sec pi over 3 then, well, that's going to be 1 over cosine pi over 3. And again, just use your calculator here if you can't remember the exact trig values. So 1 over cos pi over 3, that's 1 over a half. So cosine pi over 3, that's a half. 1 divided by a half is the same as times in 1 by 2. So we get 2 there. Okay. So now we put everything together here. So therefore, cosec pi over 2 minus sec pi over 3, well, that is equal then to 1, because cosec pi over 2 is 1, minus here, sec pi over 3, which is equal to 2. We get 1 minus 2, which is equal to -1 as required. Okay, and there we have it. So that's the solution there to question 1. Moving on to question 2 now, which says, prove that sec squared x minus cos squared x is identical to tan squared x plus sine squared x. Now with this being a trig identity here, what we need to do is start with either the left-hand side or the right-hand side and manipulate that side to be identical to the other side. So let's say we start with the left-hand side here. So we've got sec squared x minus cos squared x. I need to manipulate this using trig identities to be identical to the right-hand side here. So let's start with the left-hand side. So start with LHS, that just means left-hand side. So we're going to start with the left-hand side here, so that is sec squared x minus cos squared x. And we need to manipulate this here to be identical then to tan squared x plus sine squared x. Now, if we just look at the left-hand side here, are there any trig identities that we can use that would help us obtain this required form here? Well, we have cos squared x here, and we know from the first year material that sine squared x plus cos squared x is equal to 1. And clearly we can rearrange this here such that cos squared x is the subject. So cos squared x is equal then to 1 minus sine squared x. And therefore we could then substitute this here into cos squared x. Okay. But what about sec squared x? What can we do with that? Well, again, we can also use this identity here. So sine squared x plus cos squared x equals 1. Well, that doesn't involve sec squared x. However, if we divide through by cos squared x here, let's see what we get. So if we divide through here by cos squared x, we get sine squared x over cos squared x. We've got sine squared x over cos squared x. We have plus cos squared x over cos squared x. That would be 1. We'll write it out in full here just so you can see it. So that would be 1. And then we have 1 over cos squared x. Okay. Well, sine squared x over cos squared x, that's tan squared x. So that's tan squared x. Cos squared x over cos squared x, that is 1. And then 1 over cos squared x, that would be sec squared x. Okay. So that's sec squared x there. So now we've got tan squared x plus 1 is equal to sec squared x. We've also got this equation here then for sec squared x. So now we substitute this here and this here into our left-hand side. We should hopefully obtain this required form here. So sec squared x, like we said, that's tan squared x plus 1. We've got tan squared x plus 1. We then have minus cos squared x. This is minus 1 minus sine squared x. We'll put this in a bracket here just to make it clear. So 1 minus sine squared x. Like so. Well, clearly now, 1 minus 1, they'll cancel. I've got tan squared x minus sine squared x. So minus over minus becomes plus. So what we've got here then is tan squared x plus sine squared x as required. Okay, so as required, and there we have it. So that's the solution there to question 2. Moving on to question 3 now, where we have 2 parts of this question. So let's begin with part A. So part A says prove that, and then we've got this equation here. Now what we want to do for this proof here is start with the left-hand side, manipulate this using trig identities and the reciprocal trig functions into the right-hand side. Let me just start by writing down part A then. And like we said, we're going to start with the left-hand side here. So start with the left-hand side. So start with LHS for the left-hand side. So what can we really do here with the left-hand side? Well, we know that we need to get cos squared theta. So there isn't really too many ways we can do this. One way is that we're going to have a series of fractions and hopefully be able to cancel things out. That's one way. And given that we already have a fraction here, that to me, and based on my experience doing these type of questions, would be what we're going to end up with here. Or the other way is by using the identity then of sine squared theta plus cos squared theta equals 1. And obviously in that case, then if we want cos squared theta, so cos squared theta, that would be equal to 1 minus sine squared theta. That's the other way, but I can't at this point see how we're going to get 1 minus sine squared theta. Okay, based on the left-hand side anyway. So what I'm going to do then is start with the left-hand side. I'm going to substitute for cot squared theta then, cos squared theta over sine squared theta, because we know that tan squared theta, so tan squared theta, that is sine squared theta over cos squared theta. That's one of our first year trig identities. So sine squared theta over cos squared theta. And because this is cot squared theta, it's one of the reciprocal trig functions. So it's 1 over tan squared theta. So we just flip this fraction here. Okay. So like we said, then let's just replace cot squared theta with cos squared theta over sine squared theta. So we get cos squared theta over sine squared theta. And then this is all over. So this here is just the numerator. That's cot squared theta. We then have 1 plus cot squared theta. So again, it's going to be cos squared theta over sine squared theta. Like so. And at this point, it does look a little bit messy. So what can we really do here? Well, I can't really do anything with the numerator in its current form. However, with the denominator here, 1 plus cos squared theta over sine squared theta, what we can do now is get this over a common denominator. So in that case then, like I said, the numerator won't change. So that's cos squared theta over sine squared theta. And then for my denominator here, if we get this over a common denominator now, what I'm going to do here is times through by sine squared theta. So I'm going to get 1 times sine squared theta plus cos squared theta, and that's all over sine squared theta. So sine squared theta plus cos squared theta. Like we said, that's all over sine squared theta. Okay. Now we know, like we can see here, sine squared theta plus cos squared theta is equal to 1. So this part here, this would be 1. So now we've got cos squared theta over sine squared theta. And that's all over 1 over sine squared theta. Okay. And from here, we're pretty much done now. Basically, at this point, we've got this fraction here divided by this fraction here. So if we've got this fraction here and we divide it by this fraction, this is just the same then as timesing through by the denominator here, sine squared theta. Okay. So because it's 1 over sine squared theta, I would say it's just the same as timesing through by sine squared theta. So in that case then, the sine squared thetas here will just cancel. Okay. So in that case, then we get left with cos squared theta over 1. We get cos squared theta over 1, which is equal to cos squared theta there as we require. Okay, that's what we wanted here. So that's perfect. So as required then for part A. So that's part A done. So let's move on to part B now. Now for part B, it says hence of y, solve for theta being between 0 and 2 pi. We've got this equation here. So notice the left-hand side is exactly what we have here in part A, and this is equal to 1 over 4. So basically, because we have the same left-hand side here as what we had in part A, I can just replace that then with cos squared theta. So we have cos squared theta is equal to 1 over 4. So obviously what we want to do here is isolate cos theta on its own. So we need to take the square root of both sides here. So take the square root of the left-hand side, we get cos theta. And then if we take the square root of the right-hand side here, don't forget we have both the positive and the negative solution here. This is plus or minus 1 over 2, like so. So now we need to consider both solutions here. So let's start with the positive solution. So in that case then, I can now take cos inverse of both sides because we've isolated cos theta on its own. Therefore, theta is equal to cos inverse of a half. So cos inverse of a half there. Now obviously make sure that you're working in radians here. Like we can see, the domain is in radians. So cos inverse of a half, make sure you calculate, like I said, is in radians mode. If you do this correctly, what you should get then is pi over 3. Okay. We get pi over 3 there. Now, you either remember the rule here, or you can draw a graph, or you can use a cast diagram. So if I quickly draw my cast diagram here, it's going to be pretty small, but it doesn't really matter. I've got C, A, S, and T. So we're working with cos here. So cos is positive in this quadrant here. So this angle then is pi over 3. And then cos is also positive in this quadrant here. And again, the angle there is pi over 3. But what we're looking for is this first solution here from what would be my x-axis to this line. Well, clearly that's pi over 3. And then my second solution comes from this line here all the way around until we meet this line here. Okay, we're looking for that angle that's formed. So in that case then, well, that's clearly going to be 2 pi radians minus pi over 3. So theta is equal to 2 pi minus pi over 3. Keep this in exact form here. So that's the same then as, well, times 3 by 3. I get 6 pi over 3 minus pi over 3. And that gives me 5 pi over 3 there. Okay. So that's my second solution there. And clearly any more solutions now would fall outside of this domain. So that's the full set of solutions there for this equation here. For the positive solution, don't now forget the negative solution. So now we have theta equals cos inverse of minus a half. Okay. So cos inverse of minus a half. Again, just put this into your calculator here. And if you do this correctly, what you should get then is 2 pi over 3. And again, we also need to consider the second solution here then for cos inverse of minus a half. Because now, again, if we just refer to a cast diagram, my next solution would come from this line here all the way around to meet this line. And again, looking for the angle that's formed. So again, it'll follow the same pattern here. It's going to be 2 pi. So 2 pi minus. So now it won't be pi over 3. It's now going to be 2 pi over 3. So 2 pi minus 2 pi over 3. And again, you can see what's going to happen here. It's going to be 6 pi over 3 minus 2 pi over 3. So 6 pi over 3 minus 2 pi over 3. And if we evaluate that, we then get 4 pi over 3. Okay. And there we have it. So again, any more solutions now for cos inverse of minus a half would fall outside of this domain here. So we know now we have the full set of solutions for this trigonometric equation here. So let's just quickly define the full set of solutions. Let's do it in red here. So therefore, let's do it underneath. So therefore, theta is equal. So our first solution was pi over 3. We then had 2 pi over 3. We then had 4 pi over 3. And then finally 5 pi over 3 there. And there we have it. So what we've got in red here, that is our full set of solutions for theta. So that's the solution to part B. And that gives the solution there to question 3. So if we just take a look now at the very last question here, question 4, where again we have another trigonometric equation to solve. So this time we're looking to solve for theta being between 0 and 360 degrees to tan squared theta being equal to 3 sec theta. Now, straight away, I can see the issue here is that we have two trigonometric functions. This is tan squared theta, and we also have sec theta. So what do we do in this case? Well, what I need to do is basically get this trigonometric equation here in terms of one trigonometric function only. And the only way that we can actually do that in this case here is to use our trig identity then for tan squared theta. So we know that sec squared theta is equal to 1 plus tan squared theta. Okay, so in that case then, tan squared theta is equal to sec squared theta minus 1. And all we're going to do then is substitute that into the left-hand side here. So what we get then is 2 lots of sec squared theta minus 1. So sec squared theta minus 1. And that is equal then to 3 sec theta. But what I'm going to do here is I'm just going to do it all in one line, basically. I'm going to subtract 3 sec theta off both sides. So minus 3 sec theta. And that means then that this equation is equal to 0, which will be handy when we come to solve it in a moment. So now if we expand the bracket here, 2 times sec squared theta, that would be 2 sec squared theta. We get 2 sec squared theta. 2 times minus 1 is minus 2. We've also got minus 3 sec theta here. So 2 sec squared theta minus 3 sec theta. And then finally, like we said, 2 times minus 1 is minus 2. And this is all equal to 0. Okay. Now, obviously, what we're hoping for here is that this equation here will factorize. And in this case, it does. So the good news is that it does factorize. So what I get here then, if we factorize this, is 2 sec theta plus 1. So 2 sec theta plus 1. And then in the other bracket here, we get sec theta minus 2. So sec theta minus 2. And this is equal then to 0. Okay. So from here then, we get two solutions. So I get this solution here. So this would be when sec theta equals minus a half. So sec theta equals minus a half. So if we rearrange this here, this would be 1 over cos theta is equal to minus a half. So 1 over cos theta is equal to minus a half. So in that case then, cos theta is equal to minus 2. So therefore cos theta is equal to minus 2. However, for this equation here, cos theta equals minus 2, no solutions exist. Okay? So here, no solutions exist. In other words, if you try and take the inverse here of minus 2, so cos inverse of minus 2, you'll get an error on your calculator. You won't be able to get a solution. So no solutions exist here. Okay. However, we also have sec theta minus 2 equals 0. So in that case then, we get sec theta equals 2. So sec theta equals 2. From here, this is 1 over cos theta is equal to 2. So therefore, cos theta is equal to a half. So cos theta equals a half. So therefore, theta is equal to cos inverse of a half. So cos inverse of a half. And obviously for this one here, we're working in degrees. We can see that from the domain here. So cos inverse of a half. So that would give us 60 degrees. If you just use your calculator, if you just recognize the exact trig values here, we get 60 degrees. And within this range here, or this domain, I should say, from 0 to 360 degrees, we get a second solution. And that comes from 360 minus this angle here. So 360 minus 60, so that gives us 300 degrees there. So therefore, we can see then that for theta, the full solutions here would be 60 degrees and 300 degrees. Okay. And there we have it. So that's our solution there. So let's just kind of box this off, just so you can see the full solutions here. And there we have it. So that gives the solution there to question 4, the very last question in this video. And that actually brings us to the end of this video on exam revision for reciprocal trig functions.